In the previous lesson, we were talking about Venn diagrams and how these Venn diagrams can represent events. And in the Venn diagrams, there are specific things called outcomes. Now, to start with today, it says here, events which are not mutually exclusive. So what does the word even mutually exclusive mean is something that we need to think about. Well, if I look at this Venn diagram, there is a sample space called S. And inside of S are all the possible outcomes. These two events, A and B, they overlap. And what that means is that there are some outcomes that are in both A and B. Now, I want you to tell me what are the two outcomes that are in both the event A and the event B, looking at the drawing. Put your answers in the chat, or I'd love to hear your voice if you are willing to share which outcomes are in the event A and the event B. Who can light up my life and give me the answer? Mateo, Simumkele, Tandiwe, I like what I'm seeing. The outcomes that are in both A and B are 3 and 9. So they're in the event A and in the event B. So the events A and B are not mutually exclusive because they have a non-empty intersection, or we could say there are outcomes that are in both event A and event B. So these two sets are not mutually exclusive. If something is mutually exclusive, if two events are mutually exclusive, what you will see is that the events don't have any intersection. There are no outcomes that are common to both. So this would be mutually exclusive. So A and B are mutually exclusive, where here A and B are not mutually exclusive. Give me a thumbs up if you understand about what it means for something to be mutually exclusive, or give me a thumbs down if you're like, this man is talking gibberish. Okay, so Tandiwe, I see your hand go up. I would love to hear your question. Is there someone trying to join? Let's have a look here. Someone is trying to join us, and I must let them in. Okay. Oh, mistake. Okay, no problem. All right, now let's focus on two events that are not mutually exclusive. So these are these two things here. I want you to write down for me how many items are there in A, how many items are there in B, how many items are there in A and B, how many items are there in A or B. So let me actually do this like this. So there are 4 questions on the board, and I want you to look at our little diagram here, and I want you to work out for me what the answer is. So we'll call this A, B, C, D, and N means the number of items. So if I look at the event A, there are 4 items in there. So N of A is 4. And what is the N of B going to be? 1, 2, 3, 4, 5, 6. Okay. What is N of A and B? Well, how many events are in A and B? Well, it has to be 2. It's just going to be 3 and 9. And then what is the last one? Oh, I love it. The answers are flying in. Keep it coming, people. Lovely, Edith. Lovely, Bukle. How many items are in events A or B? So we have 1, 2, 3, 4, 5, 6, 7, 8. So this is very, very useful for the Venn diagram, being able to count how many outcomes on each event. All right, now, say I ask you, what is the probability, if you are going to choose a random item from inside the sample space, what is the probability of getting an item in A? What is, in fact, before we move on, I want to know for E, what is the N of S? What is the N of S for this drawing here? Oh, it's Pafunzo. Okay, no problem, Pafunzo. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there are 12 outcomes in the sample space. Now, E, F, G, H, I. I want you to work out what, if you choose, you close your eyes and you put your hand inside the sample space and you randomly grab a number. What is the probability of getting A? What is the probability of getting B? What is the probability of getting something that is in A and B? What is the probability of getting something which is in A or B? I'll give you a hand for the first one. How many items in total are there in the whole sample space? There are 12. How many are there in A? There is 4. And so the answer for this probability of getting A in the sample space is 4 out of 12. Get me the next 3. Get me the next 3. So I did F, A, B, C, D, E, F, G. I'll give you a little cheat sheet. All of these are going to be out of 12 because that's how many items there are inside the sample space. I want to know, what is the probability? I close my eyes, I put my hand in, and I grab. What's the chance of me getting B? The chance of getting B, I just go and look there. It's 6 out of 12. Thanks, Tandiwe. What is the probability of getting something which is in A and B? So to be in both, how many items are there that are in both? Oh, I can just look at the N over here, and it's going to be 2 out of 12 because there's only 2 items in the sample space that are in A and B, and then the last one is going to be A or B. Well, we had 8, so that's 8 out of 12. So we can take the Venn diagram and make lots of little questions based on this. I want you to give me a score out of 10 for how well you understood this first example, where 10 out of 10 is perfect, 0 is no understanding, 5 is an okay understanding but needs to improve. How would you put your understanding of this first example? Keep the answers coming. Thank you, everyone, for voting. I really appreciate your feedback. Now, based on this first example, some of you are going to see this formula in your teacher is going to talk about it in class. And so I just want to explain where it comes from with reference to the example that we've just done. So when we have non-mutually exclusive events, right? We have this thing called the addition rule for the probability of any 2 events. In fact, this actually works for everything. But it's particularly helpful when they're non-mutually exclusive. Okay, what is the probability of A or B is the probability of A plus the probability of B minus the intersection. And the same thing is true for the n. So let me show you this rule in terms of what we've done. So what is the n of A or B? It's just going to be 8. So I'm just grabbing this 8 over here. Now, that 8, if I follow this identity, then what's the n of A? Well, the n of A is 4. So that was this one over here. Now, if I go to the n of B, what's the n of B? N of B is 6. Oh my goodness. 8 does not equal 4 plus 6, does it? Can anybody tell me why have I got too many on the right-hand side? I'd love to hear someone's explanation for why, if I go, like, I'm looking at this rule here, and I'm saying the n of A or B is 8. The n of A is 4. The n of B is 6. Why don't these two add up? Would anybody be willing to put their hand up or have a go at that? Okay, Bukle, what do you think?
I'm not sure what the question
Can we
was, though, but yes, sir. Can sir hear me?
I don't know, maybe we've lost some audio, but I see lots of students are commenting in the chat. Intersection, okay. The reason is we've added these two things in the middle twice. Like if you go the number of items in A and the number of items in B, the problem is you've added the middle bit twice. And so in order to balance the equation, what you need to do is you need this little bit at the end, and you go to -2, which is the what n of A and B. And so all I want you to be aware of when you teach, I don't want to go into too much detail about this, but this identity, the reason it works, and it also works for the other stuff that we did above, because that's just divided by 12. So we can go 8 over 12 was the probability for that, equals 4 over 12 plus 6 over 12 minus 2 over 12. This is the same thing as below, except it's just divided by 12. This identity comes from this example over here. Now, I don't expect you to be perfect, but can you see, all I want to see, thumbs up if you can see the connection between this identity and the example I've just done. Give me a thumbs up if you follow how the two are connected, because in my experience in class, most students get given these rules and they have not a cooking clue like where the relationship comes from. And so that's all I want to start by showing you today. Okay, now we will use this again, but let's get going with some more examples. So let us go to this first one. So this is a Venn diagram question. So we're going to say, out of a group of, in fact, let's not do that one. Let's do this one over here. So we're going to start going through some more words and make sense of this. So there are 24 learners in a class. 13 learners decided to go to Adam's party. 12 learners decided to go to Nisha's party. 3 learners decided to go to not go to either of the parties. I want you to draw a Venn diagram that describes the situation, and then I want you to say done in the chat when you are done. So all you are doing is you are describing this situation in a Venn diagram. And when you have drawn your Venn diagram finished, I want you to say done in the chat. So let's go with an A for Adam's, people who want to go to Adam's party. Now, I'm going to take a chance and say, I think there are some students who want to go to both, but we'll see. We'll go for N. Now, what you need to do for me is you need to decide how much goes into each of these zones. You need to decide what numbers go where. And then say done when you are done. So 3 learners decided to not go to either of the parties. Well, then those 3 must be sitting out here. How do I know what goes in each of these categories here? Well, I don't know how. I know that there are 13 that go to Adam, but some of them go to both. I want to know from the class, what strategy can I use to help me figure out these zones over here? Naledi's giving some good advice. Naledi is suggesting that I could put an X here, and then this over here must be 13 minus X. And then this over here must be what? What does this part over here have to be? So for 12 going to Nisha's party, so this is going to be 12 minus X. Now, that is my Venn diagram to start with, but I would really like to know what the X value is. So what do I need to do? Well, I know there are 24 students in total. So I go 24 equals 13 minus X. Sorry, 13 minus X plus 12 minus X plus 3. Or I could have just added up the ones inside and got 21. But please work out for me, what value of X do you get for this Venn diagram? What value of X do you get for this Venn diagram? So minus X plus X, and then we've got 25 minus X plus 3. We've got X 25 minus 24 plus 3. X is 4. So I want you to tell me, okay, we've done this first one already. So it says, how many learners went to the 2 parties? Either Adam or Nisha or both. Well, this is going to be 13 minus 4, so that's going to be 9. And this is going to be 12 minus 4, which is 8. So I want to know from you, how many learners went to the 2 parties, either Adam or Nisha or both? Tell me in the chat, or put your hand up to let me know how many students went to a party. Well, it has to be 9 plus 4, which is 13, plus 8, which is 21. So the answer is 21. Oh, that makes sense, because 24 minus 3. How many learners went to both Adam's party and Nisha's party? How many learners went to both? Well, my drawing is so helpful. It's just going to be 4. Okay, now on to question D. It says, suppose one of the 24 learners is selected at random. What is the probability that the learner only goes to Adam's party? So what is the probability that the learner only goes to Adam's party? So where is, if the students, there's 24 in total, so I know that it's going to be out of 24. How many of the students only go to Adam's party? It's going to be 9 out of 24, because if I included the 4, they go to 2 different parties. They're like going to both parties. Okay, number 2. what is the probability that a learner goes to both parties? Well, to go to both, the only 4 out of the 24 will go to both parties. Lastly, what is the probability that the learner doesn't go to either of the parties? What's that going to be? Put your answer in the chat there. Yeah, it's just going to be 3 out of 24. All right. I feel like you guys are getting this. Give me, but I might be wrong because I can't see your faces or hear your voices. Give me a score out of 10 how that example went. Give me a score out of 10 for how that example went. All right, everyone, this is a multiple choice question, but what's different now about the questions we're going to do? Okay, Machadiso, I'll keep an eye out for any questions now. Please be comfortable to ask questions as we go, because I want to make sure I help everyone. Okay, I want to know what I've colored in a certain region in this Venn diagram, and there are 3 different events happening. Which of the 4 multiple choice descriptions describe that region over there? Remember, this little symbol, that is trying to be the intersection symbol, and it means and. So down here, I see lots of ends, but what they're saying actually is they're meaning and. So if I have to look at this region is in A and in B and in C. So I would write it like this, and using the notation for intersection, it would look like that. And so the correct option is B. So this is just when we're describing different regions. Now let's move to a question where we actually have 3 different things. All right, so here we go. A survey is conducted with a group of 50 learners to find out what is the most popular at the school tuck shop. They are asked if they usually buy toasted sandwiches T, salads S, or burgers B. They can choose none, 1, 2, or 3 of the meals. The survey results are shown in the Venn diagram. Okay, first question. How many people did not buy any of these things? How many people did not buy anything at the tuck shop? Look at this Venn diagram and ask yourself, how many did not buy anything at the tuck shop? And it's possible to buy all 3 things. That's why these are the 3 people who usually buy all 3 types of meals at the tuck shop. Well, there are 50 learners in total. So what I was thinking is count all the regions here. So 15 plus 2 plus 10 plus 1 plus 3 plus 5 plus 4, and then subtract them from 50. So what do we get? 25, 27, 28, 31, 36. I get that there are 40 students in here and there are 50 in total. So I get that there are 10 students who don't buy anything from the tuck shop. Gavin agrees. Everybody else, thumbs up or thumbs down if you understand how I got those 10 out here. Okay, everyone's with me. All right, let's have you do these 3 questions. I'm going to call them number 1, number 2, number 3. and I want you to read them and try and answer them using the Venn diagram that is on the screen here. So first one, what is the probability that the person buys salad but not toasted sandwiches or burgers? If you're choosing a random learner, now I'll give you a hint again, it's all going to be out of 50 because the sample space is out of 50. We know that from here. So what's the first one going to be? Well, what is salad? Salad is S. But I can't choose everything in the S. Certain things, it says not toasted sandwiches or burgers. So none of 3 and none of 5 and none of 2. So it has to be 10 out of 50. It can only be this region over here, because if I was in another region, I would also buy toasted sandwiches or burgers. So the first one is 10 out of 50. So here, 10 out of 50. What about the second one? What is the probability a randomly chosen person buys toasted sandwiches and salad, but not burgers? So there's an intersection, toasted sandwiches and burgers, but not salad. Toasted sandwiches and, toasted sandwiches and salad. Toasted sandwiches and salad, but not burgers. I am getting this region over here. So buys toasted sandwiches and salad, but not burgers. Are you with me on that too? Give me a thumbs up if you're with me on the 2. So, all right, so we're good for that one. Okay, last one. Buy salads or burgers or both, but not toasted sandwiches. Oh my gosh, what a mouthful, literally and figuratively. Buy salads. Okay, buy salads would be the whole thing, but or burgers. So they're always important. So it can basically be or both. So this entire region is fine, except now I have to exclude something. Buy salads or burgers or both, but not toasted sandwiches. Who do I have to kick out here? Salads or burgers or both, but not toasted sandwiches. I'm afraid you are not allowed to be in the toasted sandwich circle. You are not allowed to also buy toasted sandwiches. So I'm crossing that out. What is my answer going to be for this last one? Okay, it's going to be 19 out of 50. Perfect. All right, everyone, we've been working hard. We need a break. When we come back after the break, we are going to do a 3-event Venn diagram. But in order to do that properly, we need to take a break. So I want you all, I want you on your feet. So step away from your computers or your phones or whatever it is that you're doing it on. And I want you to join me in doing some exercise and some stretching. So to start with, we're just going to take 3 deep breaths. Breathe in. One more breath. Then a quick shake of the arms just to get some nice and loose. Shake of the left arm, shake of the leg, shake of the right leg. And then you know what's coming next? The blood pumping exercise, which is the jumping jack. It just looks like that. And we go in 3, 2, 1. Let's go. 1, 2, 3.
Yes.
5, 6. Thank you for the encouragement. 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh my goodness. I have done my jumping jacks. I feel like we should all turn our mics on when we do this, just so that everyone can hear our effort. Okay, tell me how you're feeling after that little bit of a exercise. Are you feeling like your concentration is like with you? Let me know in the chat. The lady's not so sure. Okay, let us begin our second part of the lesson, and let's have a look at one of these. We should do more. It's just we have limited time, but maybe one of these days, if the class gets a bit longer, we can have 2 exercise breaks, because it definitely helps us process if our brains get blood flow and air. We all know this. So maybe we should have like a 30-second break with like 10 minutes to go, just to squeeze the last bit out. Okay, how do we do a problem like this? Now, this first one I'm going to do with you, and then you're going to do the second one. But you're going to help me on this one. So it says, during a survey at school, 350 learners were asked about their favorite sport. And there's this whole mouthful of stuff here. Calculate how many learners, blah, 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 blah. All right, let's just scan for the really important stuff. The really important stuff is, are there a group of people who do all 3? And I see that 78 people like all 3 of these sports. So we say that there's a non-empty intersection, right? So when I'm going to draw this graph, this diagram, I'm going to have 3 overlapping circles. 1, 2, 3. And what I know is, because they said 78 like all 3 of these sports, the 78 is going to go here. Now, what I also need to do is label these. So I'm going to go T for tennis, R for rugby, C for cricket. It doesn't matter where these things are. And so what I need to do is I just need to make sure that they are intersecting. Give me a thumbs up if you're okay so far. All right, now I'm going to cross this out because we're done. We need to fill out these other regions. So the next thing I do is I don't go to the top. I go to the ones over here, and I go 60 like tennis and cricket, but not rugby. So 60 like tennis and cricket, but not rugby. So that is going to be that region over there, because rugby is over here, so I can't include that. Tennis and cricket lovers, they're going to live there. So that's taken care of. Now, I want you to do this in your head. In fact, I'll give you a moment. Draw the Venn diagram. Can you see where I'm going to put the 54 that like rugby and cricket, but not tennis? So 54 like rugby and cricket, but not tennis. Can you see the region it's going to? It's going to there. Okay, now 30 like tennis and rugby, but not cricket. So tennis and rugby, but not cricket. Well, I'm going to get this one over here. So the only things we've got left to get, so I'm crossing out. Look how I cross out to make sure I don't use something twice. We need 240 for cricket. So I'm just going to go 60 plus 78 plus 54 and subtract. So I go 240 minus all of that. How much do we get for that one? I actually need to get my calculator to help me, but you guys can help me figure that out. I've got my calculator here so that I don't make a silly mistake. So we go 240 minus 60 minus 78 minus 54, and I get 48. Are we getting that? I think we are. So 48. Then for tennis, I definitely see people telling me, so I go 180 minus 60 minus 78 minus 30. I get 12. For rugby, I get 180 minus 30 minus 78 minus 54. I get 18. But remember, I've got to work out this thing out here. What do I need to do to get that thing out there? Well, the total is 350, so I just have to subtract whatever all these things in the middle add up to. And so a lot of punching into my calculator, and I have to watch out I don't make a silly mistake. Let's see, what do you guys get for the number of people who don't like any of these sports? I get that total as being 300, which means this thing has to be 50. Let me know if you agree. Thumbs in the air, wave them like you just don't care if you get that. All I did was I went 350 minus all of these things. Okay, now over to you. You need to work out. Okay, we've got this already. How many learners like tennis only? Well, I go to tennis and I see it is 12. How many learners like cricket only? It's 48, because if I was here, these learners like other sports. And how many learners do not like any of the three sports? It's going to be 50. Okay, we've already done our Venn diagram, so no problems there. I want you to answer these last two questions for me. So number 1 and number 2, calculate the probability to 2 decimal places that if you choose a random learner, that learner likes rugby only, or what's the probability they like none of these sports? See if you can take from the words and use the diagram to help you. Yeah, let me go to Boucle.
Hello, sir.
Hey, how's it going? What have you got for us? Have you got something for this, or is it a question?
Actually, it's a question. The previous question where sir asked, who do not like any of the three sports? I get 53. I don't know why.
Okay, I'll check that. Maybe let me check that at the very end, Boucle. I mean, I'm not sure if I'm pretty confident I got it right, but I'll check it right at the end. Okay,
Yes, sir.
cool. Likes rugby only, it's going to be 18 out of 350, and it's set to 2 decimal places. So we are going to go 0.05 would be off 5% chance, but 0.05. And then what about likes none of these sports? Well, it's going to have to be 50 out of 350, which is in decimal language, it's 0.14 or 14%. Thank you, Callan. I see your answer in the chat. That is fantastic. So we've now explored the 3-event Venn diagram. Give me an update on your score. How are you feeling? I want to get a feel for how my students are doing so I know what sort of example to choose next. Out of 10, how are you feeling about these Venn diagram questions? We're going to do another one now, but I just want to know what level must I have them? Okay, let us do this one. Okay, so I want to give you 2 minutes to draw a Venn diagram to illustrate the results. I will then draw the Venn diagram, but for those of you who are smashing this, you can do B and C as well by yourself. But just first of all, tell me done when you're done with the Venn diagram drawing. And I'm going to give you 2 minutes. I don't want to, this is time for you to fly solo. So see what you can do. I'm going to get some water so I'm not tempted to intervene. Okay, so the first two that I would put in would be the 8 and x, but you need to now figure out the rest of the Venn diagram. See if you can figure out where the rest of it goes. And for those who are done with the Venn diagram, see if you can do B and C. See if you can do B and C. But I'd like to give a bit more time because it takes, even for me, it takes time to sort through all these words. So 26 do not like any of the three sports. Okay, well, I'm going to cross out the ones I've done so I don't get confused. So 26 must be out here. 27 preferred chess and boxing. 27 preferred chess and boxing. Well, chess and boxing is this, but now there's already 8. So if that's 27 minus 8, that must be 19. So notice how I did that, hey? I didn't say it's 27. I said 27 minus 8 because the 8 chess and boxing, yeah. 18 prefers swimming and boxing. 18 prefers swimming and boxing, but now remember, I've already got 8 over here, so then this has to be 10. 77 prefer boxing. Well, now I need to go, this whole thing is 77, so I go 77 minus 19 minus 8 minus 10, and I've got 40. 64 prefers swimming. Okay, now I've got a bit of a problem. I need to incorporate x. So what I'm going to have to do here is for the swimming here, I'm going to have to go 64 minus 18 minus x, because that's those things I've already got here. So I'm going to go 64 minus 18. And what do I get? I get 46. So this is going to be 46 minus x. And then for chess, I'm going to have 90. And then I'm going to have to take away 19 minus 8. And I get 63 minus x. Now, that's quite tough. For those of you who, give me a thumbs up if you are following what I did there. Give me a thumbs down if I've lost you as to how I'm suddenly bringing x's into the picture here. All right, so I think I've lost some of you, but remember, you can re-watch this on the recording. And so I know this is a tough one, but basically what I did was I was using these things here, and I was saying 90 preferred chess. So if 90 preferred chess, I know this has to total up to 90. So what I do is I go 90 minus x, 90 minus 8, 90 minus 19. And if I do that, I get 63 minus x for that region. The same way here, when it said swimming was 64, I went 64 for this whole circle, but I must go 64 minus 18, which gives me 46, and then I take away that x. Now I need to figure out what the x's are. So what I'm going to do is the one piece of information I haven't used is 174. So I would go 174 equals the 26 plus, so I've done the 26, then I've got 63 minus x plus 19 plus 8 plus 46 minus x. What have I got to do? Let's make sure I leave 63 minus x plus 19 plus 8 plus 10. Now, have I done the 19? I have, plus 40. What do you get for your x value? I want you guys and girls to work that out for me. Let me just check that I have incorporated everything. So 26 did, 63 minus x, done. X, done. 19, done. 8, done. 46 minus x, done. 10, done. 40, done. Okay, got all my regions. I need you to help me work out what is the x value from this equation. Now to do that, all I'm going to do is clean this equation up. So minus x plus x goes out the door. And all you need to do is move these numbers around. So 26 plus 63 plus 19 plus 8 plus 46 plus 10 plus 40. So I get 212, but I've also got a minus x. And on this side, I have 174. And so then to get x, I bring it across to the other side. And I would just get x is 212 minus 174. Are you getting 38? Is everyone getting 38? Okay, now, if x is 38, this is 46 minus 38, so that's going to be 8. And then this thing over here was going to be 38 as well, because you just found it. And then 63 minus 38 is 25. So this is going to be 25. So give me the answer for B and C. Give me the answer for B and C. Calculate the value of x. Oh, I've just got that. The answer was 38. So it is. And then what is the probability that a randomly selected learner prefers 2 types of sporting codes? All right. So in total, to answer this question, how many people are possible? 174. How many people like 2 sporting codes? The only trick is, do people who like 3 sporting codes also like 2? They do. So basically, for me, the people who like 2 sporting codes or more, it depends if you include the 8 or not. I'm going to include it, but the question's a bit ambiguous. So what is the number going to be on top here if you include the 8? So 38 plus 19 plus 10 is 67, but I'm choosing to add that thing because that's 75. Now, if they said only 2 types of sporting codes, yeah, because if they said only prefers 2 types, but because they said prefers 2 types, I'm including the 8 in the middle. So I get 75. Give me a thumbs up if you got 75 out of 174, yeah. Okay, you're with me. Now, guys and girls, I want to say today's lesson has been a bit tough. And so I want to make sure that you guys look over the recording, because if you see this a second time, I promise you it will not be so hard. It's just that there's a lot of detail. And because there's so much detail going on, I'm actually going to end the lesson at this point now, because I feel like if I do another one, it's going to overload you. So what are the main ideas for today? The main ideas for today were that it's possible to have events that have 3 circles in the, well, it's possible to have situations where we have 3 intersecting events, and we really need to work carefully from the words to figure out each of these regions as we go. But carefully using the information, we can figure out those regions. Then once we have those regions, we can use those regions to help us find the answers to probability questions. And for me, that was the summary of today. Now, you will get questions like this in the quiz this week. So we'll do a little bit of this at the beginning of the next lesson before I move on to the new topic. But yeah, give me a score out of 10 for how you are feeling about Venn diagrams at the moment.